Hello and welcome to C Programming 0 to Neural Networks. Today we are covering pointer arithmetic, and pointer arithmetic is not a giant subject in C programming, but it is a very important one. And as such, we're gonna cover the basics of pointer arithmetic and introduce it, and then we're gonna build what we can see on the I've got the wrong thing selected on the screen in front of us, which is a sort of a ring buffer, a circular buffer. Where we can sort of keep filling in data into an array, and it just sort of goes around in a circle. And we're going to build that using pointer arithmetic to make the understanding a little bit more interesting. So let's get to it. Let's get programming. So let's make a pa.c, pointer arithmetic.c. We're going to include the C standard input output library. And we're going to obviously have a main function. I've got a new keyboard, so it's going to take me a while to get used to typing on it. And we're going to make an array. So we'll start by making an array just called A, an integer array called A, and we'll initialize it with some numbers. So 12, 44, 19 and 62 will do. And what we're going to do is we're going to make a pointer that points to the first element in that array. So how do we do that? We have covered pointers briefly, but let's go through it again. We're going to make we need an int pointer. A pointer has to have a type, and we have to put a star to make the thing a pointer. I'm going to call it PA, pointer to A, which seems like a reasonable name to call it. And we're going to make that equal to, we're going to assign that the value of the address of the first element in the array that we've created. So the address of the A at position 0. And we're going to assign that address to this pointer, and we can dereference that pointer using star PA. So PA is the value of the address, star PA, or PA is the actual address, star PA is the value stored at that address. So let's print that out and confirm that all works properly. Star PA to dereference, and it's an integer, so we can just use %d. So let's see what we get. We get 12, obviously. So pointer arithmetic is basically incrementing and decrementing pointers for the most part. We can do other operations too, but for the most part, it's incrementing and decrementing pointers. So if we do PA++, what we're going to do is we're going to shift to the next element in this array. Now the plus usually it means like add 1, doesn't it? And minus means take away 1, decrement by 1. But in this context, when used with a pointer, we're not decrementing by the value of 1. We're not adding the number 1 onto the memory address. What we are doing is shifting this pointer along by the size of the type. So an integer takes up 4 bytes. So we're moving to the next 4 bytes, the next 4 byte address. And then if we do it again, the next 4 byte address again. So we're just shifting along this array by incrementing. So when we print this out now, we're going to get 44. And we get 44, and we can obviously do that 3 times, and we'll get the last element in the array, which is 62. And that's pointer arithmetic. Obviously, we can minus, we do that 3 times, and we go back to 12. So we've moved along to the end of the array and moved back to the start again. And that's pointer arithmetic, which is very handy to use if we're dealing with situations where we've got pointers to things, especially pointers to arrays. So let's make this. Let's make a circular buffer. So what's a circular buffer? It does exactly as this picture describes. So if we want to create a function like insert into circular buffer, we'll just call it add. And we call it add function. It's going to add a value into that array and then shift the pointer along to the next one. So when we call that again, we add a value into that, and then we shift the pointer along to this. And then when we add a value into that, and so on, and then we're going to go back to the start. So we go round and round and round. I'll explain what they might be useful for at the end. Circular buffers are very handy tools, and they're certainly something worth learning. They're a useful sort of mechanism to put in programs in certain situations. In fact, I'll explain now a good example of why you might use a circular buffer. So let's say have we got a green on there? Can we do a square? Let's say we've got a graph, and on the graph we've got like some data that we're rendering to the screen. It's not a very good graph, is it? But you get the idea. Now, we don't care about the old data, and we don't know about the future data. We're just rendering data that's coming in, whatever the context. It could be like audio data that's coming in an audio stream or something. We're not saving the data, we just want to see the activity. Well, a circular buffer is perfect for that, because we only need to store this sort of a range of values, and then we just want to overwrite the old values as and when they're discarded, as and when we don't need to render them anymore. So we can use a circular buffer for that. So rendering graphs, perfect for circular buffers. Dealing with audio data, perfect for circular buffers. So they're very handy tools. So let's turn our program into a circular buffer. Wrong one. Let's get rid of this. In fact, let's get rid of all this. What we're going to do is we're going to create a struct. We're going to do type def struct. I'm going to call it circle. And in it, we're going to have exactly what we had before. We're going to have an int array, and we're going to have an int star PA, which points to an element of this int array. Now, we're going to need to decide what size we want our buffer to be. So let's define buffer size, and let's make it size of 5 for now. And then we can do buffer size in there. So we're making an element of an array of 5 elements, and then we're making a pointer. Obviously these are uninitialized, this is just a struct. We need to create an instance of one of these circles, so let's do that in our main function, circle, and we'll just call it C. So because we've actually got the element here, we're not dealing with pointers here, we can do C.A. In fact, let's initialize this to 0, because we don't want any uninitialized data in our array. When we create it, if we do equals curly brackets at 0, then that'll just initialize all the elements to 0. We can also do memset to do that, but for now we'll just do equals 0. So we want to initialize our pointer to point to the first element in the array. So we do C dot PA equals the address of C.A. So this is exactly what we were doing before, C.A at position 0. We're doing the same thing again, but we're just holding this in a struct, and we're doing that for convenience, so we can pass around our circle buffer rather than having to pass around the pointer and the array itself separately. We don't want to be doing that. We want to group these together because they're logically linked, aren't they? And we're going to want to print out our buffer to confirm everything's working, so let's make a loop to do that. I is less than buffer size, I++, and we can just do a regular old subscripting style going through this array. C.A at position I, and I'm going to print out %D. And let's put a space so they're separated. So let's confirm everything's working, and we should just print out a load of zeros. So what we want to do is make an add. We'll just call it add. We'll obviously add into circle or increment circle buffer or whatever we can call it. And we just want to be able to add, like, insert a number in and let that add function take care of moving to handle the mechanism of where that's actually going to go the next time we put a number in. If we call it again, we're putting it in the next place, and we call it again and putting it in the next place. Now, we're going to need to modify the value of this pointer, so we're also going to have to pass the address of our circle, our C, when we call this function. So let's create the function. So what we're taking a circle pointer called C, and we're going to take an int data. We're actually passing this, we'll just call it the data that we're putting into it. And quite simply, all we need to do is do C. Now we're dealing with, because we've passed a pointer, we have to use arrows rather than dots. Down here we did C.PA to access that member element, but now we've passed address and we're dealing with a pointer, we have to use arrows. In structures, we have to use arrows when dealing with structure member elements when it's a pointer. We'll cover that in more detail another time. We'll go a bit more detail into structures. It's best to pick up these kinds of things by sort of doing them, by using them in a context. And the context we're going for here is more about the pointer arithmetic. So we'll focus on that. So C.A or C.PA, we need to do a reference to get its value equals data. So we're going to put that data into the value at where we're currently pointing in excuse AMY, where we're currently pointing to, and then we're going to do C.PA++ to increment the value of the pointer. And let's make sure that works. Now we should have a 12 in the first element. And if we call this again and put a different number in, 55, and we now put it at 55, and then we'll put it in the next element, and we can keep calling this over and over again. But obviously we're going to get to a problem if we call this too many times. We're going to start writing past the bounds of this array. So we need some kind of if-else in here, don't we? So we need to do if we need an if-else, don't we? So we need if we're not at the end of the array, we're just going to increment this pointer. If we are at the end of the array, we're going to jump back to the start of the array. So how do we do that? We need a conditional to check if we're at the end of the array. So we're going to say if CPA is not equal to CA at buffer size -1, which is the last element in the array because we index from 0. If that's the case, if we're not equal to that, then we're just going to increment by 1. If we are equal to that, we're going to set C.PA equals the address of CA at position 0. We're going to jump back to the start again. And now these numbers are all the same, so this is going to not make any sense. Let's change them. 99, 44, 33, 105. So the last element we enter is 105. 1, 2, 3, 4, 5, 6. So this means that when we print out our circular buffer now, the first element should be 105. What went wrong then? I've forgotten an address operator, haven't I? The address of C.A at the final position. This is a pointer, so we need to compare it to the address of, not to the actual value of. And now the first element is 105. And if we keep calling this, let's make a loop to kind of demonstrate what we're doing here. Let's put this in a for loop instead. Let's get rid of them. Less than 100 I plus plus. So we're just going to call this over and over again, and we're going to put the value of I. So we should print out 96, 97, 98, or whatever the last few numbers, and we do 95, 96, 97, 98, and 99, because we've just continually gone around this circular buffer, overwriting the old data with new data, and we can just keep putting data into our circular buffer with our add function. Now, one final thing in this video, this is kind of where I was getting to in terms of writing good compact C code. So we've made our circular buffer, we've made our add function, and it's pretty basic here. We can see what we're doing. We're putting our data into our buffer, and then we're incrementing with pointer arithmetic our pointer, or we're resetting it back to 0. This here is primed to be written as a ternary operator, as a ternary style. The reason is because we're only dealing with one value here. We're changing the assignment of CPA of our pointer to A, dependent on a single condition. Ideal for a ternary operator. So let's leave that in so we can compare what we're actually doing here. Instead of doing that, we can write CPA equals, and then we're going to put a condition instead of making it straight away equal something. So let's write condition. Then we're going to put a question mark, and then we're going to put true, colon, false. So we're going to say equal to, and then we're going to have a condition, and if that condition evaluates to true, we're going to assign this value. If it evaluates to false, we're going to assign this value. And this is a really handy operator to make compact code. And we're going to rewrite this, but it's basically exactly the same thing. We're going to rewrite it as a ternary. And what we need to do, the condition is CPA is not equal to the address of CA buffer size -1. And if that's true, we're going to do CA plus 1. We're going to increment by 1. And if it's false, we're going to do the address of CA at position 0. And we end up with this crazy looking line of code, which to a non-C programmer, this is the kind of thing that makes C programming look a bit scary. But if you think of what we're doing, we're just turning an if-else into a shorthand ternary. And yeah, we're dealing with these arrows, which are pointing to member elements of a struct. And we've got some addresses going on here, but it's all quite straightforward what's going on. We're checking if our pointer is pointing to the last element in the array, and if it's not, if it's not pointing to the last element in the array, and if that's true, we're just going to increment by 1. If we are pointing to the last element in the array, we're going to reset back to 0. So let's make sure that that all works, and it works exactly the same. And I always like doing this for any examples. Let's see how fast this function is. That 10 million, yeah, 10 million. Let's call that 10 million times. How long do you reckon it's going to take? It takes less than a second. We right to our circular buffer 10 million times in 0.041 seconds. Isn't that impressive? Isn't that impressive? I still almost find it incredible how fast computers are. Cat, this is a terrible time to be walking over my laptop. Come on, mate. So that's pretty much what we've done. We've managed to build this our circular pointer, and as I said, it's useful for sort of rendering graphs or any kind of data where you only need the current data. You don't need any of the old stuff. You don't need to save it, and you don't need the future stuff. Or maybe you do want your old data, but you just want to dump that to a file, but you don't want to continually be writing every single time a new bit of data comes in. So you can just fill up your circular buffer and then dump it when you hit a trigger point. Dump it to a file when you hit a trigger point and let it carry on reading data while the program's running. You don't lose any data, and you don't have to do too many writes to a file. And that's about it. That's this video concluded. So pointer arithmetic, to summarise, is basically incrementing and decrementing pointers, which and they move forward and backwards, or they increment and decrement up and down by the size of the data, the amount of bytes that it holds the data. So an integer pointer is going to increment by 4 bytes because an integer is 4 bytes. A car pointer is going to increment by 1 byte because a car is 1 byte. And we also have something in C programming called void pointers, which are generic pointers which point to just memory. They don't have a specific defined size. They can point to any amount of memory, just point to the first memory location. What you do after that is up to you to program. You can't use pointer arithmetic on void pointers for that very reason, because they don't have a defined size. So there's no way to for the compiler to know the hop size of how much to hop each time you increment and decrement. So you can't use pointer arithmetic on void pointers, which we are yet to cover, but we will cover. And that's about everything. And that is about everything for this part. And this is another useful program which I highly recommend everyone should write. And you'll find it useful as and when you begin to write more complicated programs. You can make circular buffers in lots of different ways. You can make a linked list circular buffer, and that's if you want a more complex data, that's probably the right thing to do. So obviously this is just for single integers. If we want something more complicated, well, we can do it the same way. We can obviously have a pointer to a struct within a struct, and increment by the size of those structs, and that's perfectly fine. But we'll need to come up with some kind of example to demonstrate that. So there's challenge, make a circular buffer. Right, anyway, I haven't made a video for 2 months, and the reason I haven't made a video for 2 months is for a very good reason. I decided to apply for a new job, and then I had a series of some interviews for that job, and then handed in my note. I got the job, handed in my notice at existing old job, and did my first week or two in the new job. So I've had a bit of a busy time. I like to give full attention to those kind of things. But one of the reasons why I've decided to make a bit of a life-changing manoeuvre is so I can devote more time to this kind of thing, to making videos, and building on my C programming series, C zero to neural networks, and I've also done a fair bit of programming on my own stuff. So go and load something up. I haven't got anything that interesting to show. I've got this, which is a very nice backprop kind of MNIST dataset kind of thing, which is good, which is I'm pretty happy with my implementation now, so I keep playing around with trial data, but that's all working quite nicely. I shall go through it in more detail. Well, we're going to build these things. I'm just building test examples to work with. I also bought a Mac keyboard as well, which is the first time I've ever had one. And the reason is, in a new job, I got deployed a HP laptop, and I persevered with it for a couple of weeks, and I absolutely despise the keyboard on it. I mean, the arrow keys are in this weird layout, and I'm used to ThinkPad keyboards, and it's not got a ThinkPad keyboard. Obviously, it's HP laptop. And looking around, all the other people I work with have all got mechanical keyboards, so I thought, you know what, I'm going to get a mechanical keyboard. I always thought they were a bit... well, I didn't take them very seriously. I'm a bit of a mech skeptic myself, and I finally decided to get on board with getting a mech. So I spent £100, which is a reasonable amount of money for a keyboard, and got a pretty plain looking mechanical keyboard. I can't make any recommendations on keyboards because I don't know much about them, but I did do a bit of research to make sure I got the kind of switches that I liked. I got black switches because they're a bit heavier to press, and I'm quite heavy-handed with typing, and they're relatively quiet. So those two things were my criteria, and yeah, I'm really happy with it. The build quality is absolutely phenomenal. From the moment I got it out of the box, I was like, this feels really good. This feels really good quality. It's a brand called Ducky, if you've ever heard of them, and apparently they're well known for build quality, and I just wanted simple, good build quality. So I'm a convert. I'm a Mech convert. I'm currently practicing using my Mech because I'm so used to typing on just a ThinkPad keyboard that it's going to take a bit of getting used to. And I'm a bit of a clumsy typer anyway. I'm miles better. When I turn camera on, my typing accuracy goes down massively. I don't know why, but I'm a lot more accurate and a lot more less mistake prone when I'm just programming quietly on my own. I'm hoping that doing this video series, is going to improve my video recording typing accuracy immensely. In fact, it's something I'm working on with every part I make now. So apologies for the big break, and this was a bit of a just let's get going again video. But it is a very important thing, pointer arithmetic, and building circular buffers is one of them simple things that you can build when you're quite new to C programming that actually starts feeling like you're a proper C programmer, because you're writing these kinds of lines of code, which for someone who's new to C programming, look at that and go, what is that doing? What is this crazy foreign language, this mad alien terminology? We've got address operators in here, we've got a question mark, and we've got this colon here. Well, when you break it down, it's pretty straightforward, isn't it? It's just a ternary operator, so it's basically an if-else, condition, true, false. And we're dealing with addresses because we're dealing with pointers. But the structure's really simple. It's just an array of a fixed size, and it's got a pointer pointing to one of the elements in the array, and that's it. Simple. It's really simple, but really useful and really effective, and really flexible program too. We can maybe change that to 20, and we can use the same program and print out the last 20 elements. Oh, I'm still on 10 million, am I? I thought I'd put that back to 100. Obviously not. Put that back to 100. And then we print out the last 20 elements. Really, really useful, handy, flexible mechanism is a circular buffer. Let's get rid of this now. Make this code nice and compact. And then that's our add function that makes our circular buffer work. And we'd probably want to make a print circle function as well, because here we're always starting at the beginning of the array, but really we want to print out from the part of the last element of the array. If we put an unusual size in, I'll show you what I mean. If we put like 13 as a size, it starts off 91, 92, then it drops down to 88, 89, 90. We always want to print out a circular buffer really from the last element that was put in it, or or backwards or whatever. We can control that if we made a function to do it. Anyway, so let's get back on with this series. Let's build up to our neural network implementation, and let's figure out how to build Star Wars droids and solve this problem, this artificial general intelligence problem that everyone is obsessed with on things like social media, Twitter, aren't they? It's a main topic of conversation at the moment. Let's figure this stuff out. I am absolutely determined to get a computer that works like a Star Wars droid, that you can actually have a conversation with. It's become my main goal in life is to achieve that. Hence this series, so that it becomes an essential part of my life. Right. As of the next part, we'll be up and running. We're gonna definitely with my current job, I'll definitely be able to do consistently several videos a week. I'm going to try and do minimum 3. I should be able to get up to maybe doing 5 a week. And we're just going to go through C programming and all the little bits of C programming, do lots of different threads, but keep that main thread of building up our neural network implementation. And anyone who's following along, we're all going to become AI experts and geniuses. And we're going to figure out Star Wars droids together. Right, I'll see you next time. Goodbye. Oh, I've got to... I put a KVM switch on so I could use my same keyboard. I have to say goodbye again. And... yeah, I may have to get another mouse for my main computer because I streamed it. I'll explain it another time. Anyway, goodbye.